Good morning, everybody. Good afternoon. Welcome to the 2022 FAIR SPARC Codeathon. We're so pleased that you've joined us, and we're looking forward to a new format this year, as well as just seeing the creativity and what you bring to SPARC this year. So welcome. My name is Sue Tappan. I am a developmental neuroscientist, and I work with the SPARC program as part of the Knowledge Management Core. And I'm joined by Elisabetta Ivarone, who is a computer scientist at in the simulation core. We have members from all groups of the SPARC community to serve as mentors through the Codeathon. And so I just want to start off by saying what the goal is. Our goal is to use SPARC data or SPARC tools and resources in novel ways to demonstrate or measure the fairness of data and tools present in the SPARC ecosphere. The requirements for the Codeathon are that projects must demonstrate the value of our public data and or directly integrate with any of our SPARC tools to improve their existing capabilities. So your end user is really the SPARC community of scientists, educators, data scientists, anybody who could make use of the data that's present on the public portal to enhance their ability to understand and innovate for neuromodulatory advancements for bioelectronic medicine. The project categories this year that various groups are going to be working on are listed below. You'll recognize which group you're in, and just to give you an idea of what we did last year. Last year was a much different Codeathon. There's a few people who participated last year who are participating this year. Welcome. Welcome back. Last year we had a global Codeathon, and it was actually 15 days. So we went from 15 days to a little under 3 days this year. So we're really, spreading the gamut here on the projects framework here. Last year we had you can see the skill set of the participants who participated last year. So you can see that really we have a similar makeup this year. We're very, very excited that everybody has joined and that your skills are going to come to bear to create some really cool things. In this case, we have made special effort to match time zones as opposed to trying to create teams that were equally spread across all time zones. That was something that could have been possible in a longer Codeathon, but for the short Codeathon that we have here, teams are time zone matched as much as possible. You should be attached to your Slack team already, and you will be able to get to know your team now. So we'll just go over very briefly what's at stake. In addition to just the intellectual opportunity to apply your skills and learn about that application in novel and interesting ways with new people, we're interested in judging the projects on the quality and completeness of your code, your documentation, and your recorded presentation that summarizes your project for the judging panel. Because this is a short Codeathon, we're not expecting that you become experts in our resources. We are here to help you ensure that you're able to apply your idea to the mechanisms that we have built so far. And so the documentation of both how you document your code as well as how you present your material in the approximately 3-minute recorded presentation is really what's going to help us understand what your idea was and how you think it can improve or impact the SPARC research community. There are prizes at stake. We are offering a first prize of $20,000 US to be distributed by the team within the first place team. And then second prize and third and fourth prize are also cash prizes. So I'm hopeful that everyone is quite excited about this opportunity.
Welcome to the presentation of the project transcriptomic data visualization. We present to you the new SPARC template, name it expression, that allows the visualization of gene expression data. The pipeline will define differentially expressed genes and not differentially expressed genes, and then it will divide differentially expressed genes into upregulated genes and downregulated genes. And the genes will be also represented in a volcano plots. Next, the ontology of the differentially expressed genes will be defined, and 6 plots will be generated corresponding to the biological process of the downregulated genes, the biological process of the upregulated genes, also the cellular component of the down and up genes, and finally the molecular function of the down and up genes. If you do have two datasets, you can compare the two genes' expression level. So first, you can get a table defining the number of each profile genes, and next you can get a CSV files that for each gene give you the expression profile of it in each dataset so you can compare by yourself. So next, how you can use it? We provide a Chrome extension that will guide you through all the steps. If you don't have already data, you can download datasets from the SPARC Portal database. Also, our extension will guide you through all the steps to download the data from the SPARC Portal. If CSV files are provided, it will inform you that you can directly visualize this data. And the provided link will get you directly to the SPARC template. If only raw data is provided, it provides for you a script that you can follow to process your data. The extension is available in the GitHub repository. You can download the folder and then install it using the Mode Developer.
Good afternoon and welcome to the presentation for Team 6. We are Team Curated Tutorials, and our project for the SPARC Codeathon is to build tutorials for the SPARC ecosystem and host them in an online hub. The NIH SPARC initiative has developed an ecosystem of open source tools and carefully documented sets of data underpinned by the principles of FAIR, which are now primed for utilization by people within and outside the SPARC community. However, we see an opportunity to lower the barrier for entry into the SPARC ecosystem because many existing tutorials show in detail how a particular SPARC tool can be used on its own, but do not document how these tools can be used together for building workflows. We have developed a hub for online tutorials with the goal of realizing the potential of the tools that are currently available within the SPARC ecosystem. We have populated the hub with tutorials that demonstrate how SPARC tools can be used for unified workflows. These initial tutorials lay the foundation for what we envision to be a series of tutorials hosted on our hub that serves as a place for new and current members of the SPARC community to learn about ways in which SPARC tools can be used collaboratively. We expect this to empower a broader user base to access and use SPARC data and tools and grow the SPARC community. Our platform will be a place for the SPARC community to actively contribute tutorials and share with others within the community. Our online tutorial hub is accessible via website and provides a list of all available tutorials. Our first tutorial shows users how to map 2D spatial neuron data onto a 3D rat stomach scaffold. We use Pensieve Web API for data acquisition and SPARC scaffold mapping tool to produce a WebGL encoded mesh of the rat stomach, which was then converted to STL and visualized within a Jupyter notebook. The result of our tutorial is an interactive figure in Jupyter Notebook showing the projection of the 3 types of neurons on the surface of the rat stomach. In the second tutorial, we make use of the same workflow, but instead of projecting 2D data onto a 3D scaffold, we demonstrate how the 2D data can be processed for computational simulations. Statistical processes are used to compute a probability density estimation of neurons on the surface of the stomach. This density function can be used to simulate networks of neurons that are generated using data-driven probability functions. In summary, we have produced a generalized unified workflow for acquiring experimental data and processing it using only resources from SPARC. Our approach is creative because it encapsulates a workflow within a Jupyter notebook, which is designed to be readily accessible to new users of SPARC. Having a hub of tutorials that can be easily engaged will not only accelerate growth of the SPARC community, but also increase uptake and usage of tools by members within the community. Thank you for your attention, and we hope you enjoy the tutorials we have created.
Hi, my name is Chloe Hoff, and I'm going to quickly talk to you about Sparklet, a Python package that we created in the last couple days. So here are my contributing team members that I worked with. So it started with the project that was interacting with flat maps using Leaflet and Jupyter Notebook. We decided to go down the path of using IPy Leaflet because of Python being such a popular language, and we thought it'd be more accessible to researchers. It also reflects the package Leaflet. Leaflet uses JavaScript to interact with maps. So how we export the flat maps from SPARC. You send a GET request to list all the accessible flat maps that the server holds. The server will then return the flat map IDs within a JSON container. So then what do we do with the map IDs? They can be used in many different ways. So for example, you can get a SVG file, an MB tiles, metadata, except header, which is JSON telling you the min and max zoom and bounds, and the annotations that are used on the flat map. And so all these have the URL that corresponds to retrieve that type of data. So with that, once you get the image layer, you can pick the desired image layer from the response from the server, and then you will use the URL listed at the end of the arrow to get the tile layer in IPy Leaflet. And you can do the same with vector tiles below. So some additional widgets we added was a split map where you can look at 2 maps side by side, not only SPARC flat maps, but as well as an image or a flat map from any other database. You can apply annotations from metadata to the flat map, so the nomenclature of the anatomy is viewable. You can hover over the map and get real-time feedback, as well as markers on the flat map that have defined anatomy. You can also draw on top of the map with polygons, lines, and even text. And there are even things such as heat map add-ons and animated ant path add-ons, which is an animation. So here is our Python package, which is Sparklet, which is accessible to anyone. And here you can see all of the add-ons used on a single map. So we can look here, which is a tutorial that uses every single add-on. Here is just the display of a map. As you can see, what is zooming out, these are the markers, which give you titles to every single anatomy. Here you can remove and add back the markers if you want to view the anatomy without the markers. And here is a view of the drawing capabilities for annotation purposes. You can even finish, and then even clear after. And we are currently working on a search bar. This is future work. There needs to be a couple more methods added in the leaflet. We want to be able to add any type of anatomy into the search bar, and it will pull up on the map for you, as well as some data that corresponds with that anatomy. And then finally, there are many others here that you can do, but here you can see the hover technique, which in the bottom right corner, you can see the anatomy pop up. And here it shows that you can use all at the same time, like I showed before. The hover, the annotation, search. And finally, you can save a map as an HTML file to the computer. I hope you understand and enjoyed what we have to offer. Thank you so much.
Hi everyone, and welcome to the SPARC presentation. Well-curated datasets are the foundation of the SPARC project. A SPARC dataset comprises of an experimental protocol and data files organized in the SPARC dataset structure, or SDS. This structure has been adapted from the brain imaging data structure, or BIDS. The SPARC community have developed a step-by-step interactive tool, SODA, for creating datasets for curation. However, one of the problems is that there's no publicly available approach for programmatically accessing metadata fields in these SPARC datasets. And also, there's no publicly available approach for creating new SPARC datasets. So this limits the application of FAIR principles for researchers to interact with SPARC datasets. It also limits the development of novel tools that make use of these datasets. So our solution to this problem has been to develop SPARC FAIR, the SPARC metadata editor. And this is a Python tool that allows us to explore, enhance, and expand SPARC datasets in accordance with FAIR principles. We've created a number of guided tutorials that will showcase how users can use SPARC to help them in their research. This includes the ability to download existing SPARC datasets, create new SPARC datasets, interact with these data sets on OSPARC, and also how we can extend the SPARC dataset specification with descriptions, for example, from the data use ontology developed by the GA4GH. And this provides, this tutorial specifically provides an initial attempt on how we can start to use the SPARC dataset structure to store clinical data. We've also provided a tutorial as a first step towards how we can start to convert BIDS datasets to the SPARC dataset structure. In terms of impact, SPARC will help support the SPARC DRC and community developments. It will also help support interoperability with other initiatives. For example, we can try and use SPARC to help map the SPARC dataset structure to data dictionaries that are used in popular research platforms such as the Gen3 Data Commons, which is used across a number of different research initiatives. We can also use SPARC to help enable extensions to the SPARC dataset specification to look at how we can start storing results from digital twins, which are being developed for precision medicine. I'd really like to thank our team for a great collaborative effort over the past few days. And I'd also like to acknowledge the SPARC program and also our SPARC Codeathon mentors. Thank you very much.